Hi there! In this video we're going to get acquainted with our Arduino kits that we're going to use in Bioengineering 10. So this serves two purposes. First, we're going to do a little bit of setup and make sure that your Arduino is ready to use for Design Challenge 1. And then we're also going to look at some of the other parts in the kit and go briefly over what they do so that later in the quarter when you're designing some of your own projects, you'll know what you can do with the different parts in this kit. There's quite a bit in here, so let's jump right in. Here's my kit. And it comes with a little list here of all the components that are in it for reference, so you have that to look back to if you want. Here's the insides. It comes with a CD that we won't use, so I'm going to toss that one. Now, they pack a lot of stuff into a little kit, and so if you're like me, you might find that you're going to have a hard time getting it all back in here after you start working with some of these things. So you might want to have a second little box or bag or something handy to put some of these components into, because they probably won't all fit back in here when we're done. Okay, let's jump right in. This here in the bag is your Arduino. Let's open it up. You'll notice that this particular Arduino doesn't say Arduino anywhere on it. It says Elegoo Uno revision 3 here. This is an Arduino clone. It works just the same as an Arduino. There it goes. It works the same as an Arduino, and we program it using the same software tools. So that's what we have to work with in the class. So we're going to, in later points in the class, dig deeper into how this works. But for now, I'm just going to set it aside and look at some of the other components in my kit. Now, probably the first one to show is this. It looks a bit like the Arduino, and that it comes in a bag. But after I open up the bag, I'll see it's actually what's called a little two parts to it, a little Arduino Shield it's called. This is a board that can plug into the top of the Arduino, and I'll show you that when I'm done setting it up. But this has a few little components and convenient little features on it. We'll be using this for as a substrate for building circuits in Bioengineering 10, but instead of soldering directly to these pads here, what we're going to use is this little component that also came in that bag. This is called a breadboard or a prototyping board. You see it has rows of holes in it. The holes are arranged in columns of 5 and then lots of different rows. Now we'll talk about this more in depth later, but all of the columns of 5 are electrically connected together. So that's set to say that this hole, this hole, this hole, this hole, and this hole behind the scenes inside this prototyping board are actually connected together by one piece of metal. So if I plug 2 or more things into a column of 5 holes, those components will be connected together electrically. So let's get this set up for use in Design Challenge 1. This has a adhesive back to it. I'm going to peel off the adhesive liner, pick up my little Arduino Shield again shown here, making sure I'm orienting this the right way. The pins here you see are facing down. That's the part facing down will get plugged into the Arduino. So here on top where I see these sockets, these black sockets shown here and here, this is the side that I'm going to work on, and that's the side I want to attach my breadboard to. So there it goes. I'm going to put it down just right in the middle of that circuit board area there and press it down, and there you have it. That's how it should look. I have my prototyping or breadboard shown here with all those pins where I can insert components, and then I have these rows of sockets here and here and here. Those make electrical connections with the Arduino through these pins, and then in turn I can build circuits by connecting to these points here. So let's attach that to the Arduino now. So here you see them lining up. There it goes. And I'm going to make sure all the pins are lined up just so, like there and like there. And then I can carefully push this together like that. Be careful when you're pushing on this side of it. Some of these pins are a little sharp and don't want to hurt your finger. And there it is. There's our Arduino. Wait for the focus to come in. There it is. Here's our Arduino with the shield on top of it, and our prototyping board attached as well. So this is ready to hook up to your computer with this USB port here, and then we're ready to build circuits on top of the little prototyping board shown here and connect it to the Arduino via the connection that we just built there. All right, so that's ready to go. Let's set that aside and look at some of the other parts in our kit here. Well, first, you recognize a little USB cable, of course. Now, this is an old school USB cable. This is the end that will go to the Arduino. This is the end that would go to your computer. If you have a more modern computer, especially the more recent Mac computers, they don't have this port on them anymore. They come with USB-C ports, so you'll have to get an inexpensive little adapter for making that conversion. If you don't already have that adapter, they're only a couple bucks on Amazon. I can give you some tips if you need to get one of those. That's the USB cable. What else do we have? A few of the parts in here are just mechanical parts that can be useful for some projects. For example, this is the first of several parts that move. This is just a regular DC motor. The wiring is simple. It's got just a positive and a negative connection to it. If you send about 5 volts into this, that shaft will turn, and they include a cute little fan that you can attach to this if you are so inclined. So there you go. So that's the DC motor, the simplest of the motors that come with it. A more complex motor is this one. This is a stepper motor. Now, we won't get into much detail about how these work in this class, but suffice it to say these are a bit more complex than the DC motors. They're more powerful, and they have the advantage that you can, in software, tell this shaft what angle to turn to, basically, and it will do that, or you can tell it how many steps to move in a particular direction. So these are very strong motors and very useful in a lot of, for example, biomechanics applications, where you want to be able to control rotary motion for some reason. So that's the stepper motor. Being a bit more complex, it has its own additional circuit that's required to run it. That's what this little guy is. So let's open it and look at it, just to acquaint you to it. This has a little integrated circuit in it called a Darlington array chip, and this basically controls the power to that stepper motor. Now, to use it, we'll see that these two line up in a certain way. I plug this end of the stepper motor wire into this board, and then I'll still have to make some electrical connections to these points here, to my Arduino, to make this work. But for now, this is most of a functioning stepper board setup for using with your projects. So that's the stepper motor. So the third motion controller that comes in your kit is this one. This is a very powerful tool called a servo mechanism, or a servo for short. These are used, if you ever played with model airplanes, you might have come across these as the sort of little mechanisms that control the flaps and the wings and things on a model airplane. So this has with it the servo itself, plus some additional little hardware. These are the moving bits. These are the little arms that will go back and forth and move. Now, unlike a DC motor, which can turn continuously, or the stepper motor, which can turn in any one direction continuously, a servo only turns generally a prescribed amount of angle, for example, 90 degrees or 180 degrees. And you tell this motor through the software, through the Arduino, you basically electrically can tell this motor exactly what angle to turn to, 45 degrees, 180 degrees, and it will turn one of these little attachments to that angle, whatever you desire, like this. So I won't get into the detail of showing you these, but these are very powerful little tools in a lot of bioengineering projects, where you have some sort of mechanical part that you need to make sure is turned to a particular angle, like 45 degrees or 90 degrees. And they're very inexpensive, so you can get a lot of these in a project and run them fairly cheaply. All right, that's a lot of the motion ones. Now, in terms of a motion sensor, here's one. It's in 2 parts. This is a joystick, actually. I'll flip it over so you can read maybe some of the connections there. This is a joystick like you'd find in a game controller, like on your PlayStation or whatnot. So to make it work, you see it has a pin here that's got, it's a little elongated in one axis. It's a slit, and there's the corresponding hole on the joystick connection. So if I put these together like that and jam that down, I have my 2-axis joystick. I can go up and down, left and right, a combination of those. And then it also functions as a switch, so I can push down and it will make a click and complete a circuit. So if you see the wiring details here on the side, this joystick actually works as a variable resistor. Each axis, the x-axis and the y-axis, has inside of this a variable resistor. That the resistance of which changes as a function of what angle the joystick is at. So it's very easy to write a little program on your Arduino that uses one of the analog inputs on your Arduino to measure a voltage coming out of this, and use that to infer the resistance, which in turn tells you which way the joystick is turning. So a handy little tool for controlling a lot of your projects. All right, what's next? Speaking of controlling and interfacing with your projects, we will use this quite extensively. This is a 2-row alphanumeric display. It comes with a little bit of film, protective film on it that I'll remove. And there you can maybe barely see the detail in the reflection there. I won't make this circuit yet and power it on, but this makes bright blue alphanumeric letters or numbers when you connect it via this fairly large number of pins here, when you connect it to your Arduino circuit. So you've seen these sorts of displays in cash registers or gas pumps or whatnot. They're very, very handy. And because the Arduino is such a simple little computer, simple little microcontroller, it doesn't have any sort of output display built into it. So for applications where we need to build something and have a user interface with it and actually see a measurement or some value coming from the Arduino, maybe navigate a menu or something, this part here ends up being super useful. So we will definitely be using that in Bioengineering 10. Now connecting it up is a bit challenging because of how many pins it has, but we'll talk you through that. Speaking of controlling your circuits, your kit comes with this cute little infrared remote to run it. It has a battery inside of it. To enable the battery, you just take this little piece of plastic out and you are good to go. And so this is, it's an old school infrared remote. You can, using some software libraries that are part of the Arduino programming setup, you can pretty easily write a program that can sense and tell you when one of these buttons is being pressed, and then your program will react to it. So this ends up being actually a pretty rich and sophisticated way of controlling an Arduino. Now this is just the infrared remote. Of course, you're going to need a way to detect that infrared signal, and the Arduino comes with that as well. It's buried down here in the corner, and I'll show it to you. This is an infrared receiver. It's another little LED diode, although instead of being a light emitting diode, in this case it's a light sensing diode, and it can detect infrared light. It's living inside of that little metal shell there. And so with pretty simple wiring, we can hook this up to an Arduino circuit, and it will listen for the output of this. So then it's left up to you to figure out the logic of, oh, if I press the 2, then do something. So that's a really handy little remote that comes with the system. Speaking of other readouts, the classic little 1, 2, 3, 4, 5, 6, 7 segment display that again you've seen on a cash register or a gasoline pump or all sorts of things throughout your lives. This comes with a little protective film on it as well that there we go, that you can peel off when you're ready to use it. Now the wiring for this one here, which has obviously 4 little digits that it can show, the wiring for this one is a bit more complex. You see there's only 2, 4, 6, 12 pins back here. So clearly there's more than 12 lights on the front here, right? So clearly it's using some sort of internal logic here so that you'll be sending data at a more sophisticated format to this thing to tell it what number to put out on the front here. And there's tutorials online that can show you how to do that. So it's relatively straightforward and a handy little thing if all you're going to do is display a number. If you're just displaying a single number, here's an even simpler 7-segment digit display. Has another sheet on top of it for protection that we can remove. Now when I look at the pins on this one, you see this has how many lights on the front? 1, 2, 3, 4, 5, 6, 7, 8, if I count that little decimal point. This has on the back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pins. So there's more pins on the back than there are lights on the front, and that tells me that this one here is a bit simpler to control in an Arduino circuit. If I just put 5 volts on one of these pins, a corresponding segment up here will light up. So this is if all you need is 1 digit of output, this is a relatively simple little component to add to your projects. Okay, what's next? Well, we're talking about sensors probably next. This is a really handy, very cool sensor that comes with your kit. This is an ultrasonic transducer. You see these little two can-shaped things. These are actually, think of them as a speaker and a microphone. They're actually the same part, but they function in different ways depending on how you wire them up. This one over here is an ultrasonic speaker. You see it's the speaker because it says T beside it, meaning transmit. And this one over here is the exact same part, but it's configured to be a receiver. So what does this do? Well, it's like radar or sonar, or kind of like ultrasound. This one here puts out an ultrasonic ping or a chirp that you can't hear. The frequency is too high for humans to hear, but that sound wave goes out, it bounces off of an object like my hand here, and then that reflected sound wave goes back to the receiver, which detects it there. So by measuring, for example, how much time it takes for that sound wave to make this trip from there to there to there, you can tell by knowing the speed of sound, you can tell how far my hand is from this sensor here. Or you can measure the speed of sound in a gas using this. So a longer delay means a longer distance between this and the object that's reflecting it. A shorter delay means a shorter distance. So this is a super handy little component. It makes it easy to detect motion and can be useful in a lot of neat little bioengineering projects. That's the ultrasonic transducer. What else have we got? Here, just a whole bunch of garden variety jumper wires for building your circuits with. So remember, these are what will be plugged into my little breadboard here on top of my Arduino when building a circuit. So a whole bunch of those that are quite handy. Let's talk about other little components. We're getting into the fundamental stuff here. Resistors, a nice little bag full of resistors of various values. You remember back, hopefully, from a physics class, how resistors are rated in ohms. And each one of these little strips, of course, if you can remember the color code of resistors, you can read off looking at, let's see if we can focus. You can look at there they are. You can look at the sequence of colors on these resistors and read off what the resistance value is. But if your eyesight's as bad as mine is these days, you might want to just refer to the little labels down here. So let's highlight those for a second. These are 2 kilo ohm resistors. These are 100 kilo ohm resistors. These have no suffix to them, so that's a 330 ohm resistor. 10K, 10 kilo ohm resistor. 1K, 1 kilo ohm resistor, 1,000 ohms. 1M, a 1 mega ohm resistor, or 1,000,000 ohms. This one here says 100, so 100 ohms. This one here, in a lot of the kits, is handwritten for whatever reason. It says 220, so that means that these resistors are 220 ohms. These last two here are 5 kilo ohms and 10 ohms, respectively. All right? So those are our resistors. Oh, what's next? A few more jumper wires of a different sort hidden under here. The jumper wires that I showed you before had pins on both ends. This particular set, which are currently connected in a ribbon sort of configuration, these have pins on one end and sockets on the other. So these can be handy when interfacing a component that has pins itself on it. You can insert the pins into this end and then insert these pins into your prototyping board. Now, these come as one unit, as a ribbon. You can leave them that way and then use the color to figure out which wire goes to which, or if you need them to be separate, you can gently pull them apart, and you can have sets of 3 or 2 or whatever. So here's a single wire from that bunch. You can see the socket on one end and the pin on the other. All right, so those are there ready for you to use. Some more elementary components. LEDs. Let's look in these just real quick, because I'll show you that there's 2 basic types of LEDs inside here. You see nice colorful single color LEDs. You can look at this one up close here. You see the longer lead of the LED signifying the positive connection, or the anode of the LED. So when you're powering these up in a circuit, I know that this lead here, I'm pointing at with my thumb, is the one that I'll connect the positive voltage to. The other one will go to the negative voltage or ground. So there's all sorts of nice colors, as well as some white LEDs that just put out white light. And then these guys, which are worth looking at in a little bit of detail. You see, this looks like one LED, but it has, let's see if I can get the camera focus to cooperate. There it goes. It has not just 2, but 4 leads to it. Now, this is actually a RGB LED, meaning it can put out red, green, and blue, and any combination of those. So in this case, if memory serves me, the electrical connections are inverted. The longest of the 4 pins, the one I'm tapping here with my thumb, is actually the ground, the negative connection in this case. And then the other 3 correspond to red, green, and blue. I can't remember which one's which, but you could build a circuit and figure that out, or look up its data sheet pretty easily. So these are handy. They make 3 different wavelengths of light, red, green, and blue. If you combine them all, you can then combine those into other colors that we can see that are based on combinations of red, green, and blue. So these can be actually quite handy in bioengineering applications where you want to see how light of different wavelengths can interact with a sample, which is a pretty fundamental measurement capability in bioengineering. Okay, a couple more pieces. Let's look at this guy here. Here's the second of the 2 solderless breadboards or prototyping boards that we get in our kit. I'm going to open up the package. You can see this one is what you want to use when you have a large circuit to build. So we'll do a lot in the class with this little guy, just because it's convenient, because it piggybacks on top of your Arduino, which is awfully convenient to have everything in one piece. But for really complex circuits later on in the class, you might find you want to use this. You see it has the same arrangement of holes that we talked about before. Every set of 5 holes in a column is connected together electrically. So everything in row 20 here, for example, those 5 holes are all connected together electrically, but they're separate from row 20 or from row 19 here, where those 5 holes are connected separately, and so on and so forth. And then this particular breadboard I wanted to show you just because it has an additional feature to it. It has these sort of bus lines or rails or whatever you might want to call them to them, positive and negative connections here at the top and the bottom. These are unusual. Instead of being just 5 connected like these, here the entire row alongside this color is connected. So for example, all the pins next to the red line here are connected together. So all of this top row of pins are electrically connected together. That means if I say connect a wire here and connect that to, say, a 5-volt power supply, then I can use another wire, like this one, to get 5 volts anywhere in my circuit that I needed. I could connect here or here, any of this top row of holes, or here. All of these will have 5 volts available to me. If I wanted to have a ground connection that's common between all of them, I could use the blue row of holes. Say that's 0 volts or ground, and that means that here and here and here, all those connections give me a convenient source of ground. Now, I have to wire them up to my power supply to take advantage of this, so real often when you're using one of these, you'll see 2 wires stuck into the end like this that go to, say, 5 volts and ground, and then that means that the whole rest of those 2 rows of holes are available to me to use in my circuit. Now, just because I've connected these doesn't mean that these are connected. They're not. This is a separate row, a separate set of 2 wires down here. This is separate from that. So if I want to use this one as well, I'll have to make a separate set of connections to it. Okay, this one has a sticky back to it as well, but I typically just leave that on because I don't really need to stick it to anything. What's left? A little accessory for that breadboard is this odd looking little board here. So this has got a number of little things on, a little switch, a connection for power to come in, a USB port, and then a few little sticky pins here on the bottom, which are actually meant to, check this out, plug into this. So you see I can line it up so that those pins there insert into those rails or those bus lines that I was describing. Then this little circuit board does the job of making those connections to these wires and these wires. It doesn't do anything to these columns of wires, but it makes those electrical connections. So what's that good for? Well, I can use another component I have, this little 9-volt battery wire. And I can take the little 9-volt battery that they've given me, which is so well shrink wrapped that I'm probably not going to be able to get this off in this video. There we go. All right, so connect up my 9-volt battery to my wire. I can plug this end into here, and you see that little LED there turned on. Here's a switch where I can turn that power on and off. Now, when that's plugged in, that 9-volt battery is doing the job of giving me voltage and ground on these 2 lines shown here. I can use these little jumper blocks here to specify which one is which. So here, this one's configured to be putting out 5 volts and ground. This one here is configured to be putting out, I think, 3.3 volts and ground. So it takes a little bit of playing with it if you want to use this. This isn't something that we'll get into detail too deeply in the class, but this makes for a really nice, handy way of making a standalone circuit that doesn't require a USB connection to the computer, for example, to power your circuit. All right, let's turn that off and set it aside. What are we left with? Oh, a few more little fundamental pieces that I'll acquaint you with. This comes in 2 parts. This is a variable resistor. It's 10 kiloohms, and we will be using this in the class, so it's good to acquaint you with it. Here's the dial or the knob part of it, and so to make it work, you just jam this part into this. There it goes, like that. And then this is like a volume knob. I can turn it up or turn it down. And the resistance of the component depends on the angle at which I've turned this little knob. So we'll talk more detail about that later on in class, but this is the variable resistor that comes with the set, and we'll be using that in the class. Here is another very cool sensor. I'll tell you its parts so that you can search for it if you want to use it. This is called a DHT11 temperature and humidity module. So this is a, let's see it in focus here. Inside that little blue box is actually 2 pretty sophisticated little sensors, one that's a temperature sensor and one that's a humidity sensor. And so using just these 3 wires and a sort of slightly more complex protocol called I2C or I2C, which you can Google and learn more about. It's a neat protocol that requires very few electrical connections. Using that protocol, you can very easily write a program that will read these sensor values, can tell you humidity and temperature. So what's that useful? Well, I guess if you're building a weather station, it's kind of handy. But humidity and temperature obviously are important biomarkers and values in a lot of bioinstruments. You can, for example, breathe on this after you wire it up, and it can easily detect the humidity and the temperature change in your breath. So this could be used in, for example, a respirator to detect breathing rate or things like that. So a very handy, very tiny, very simple little sensor for measuring temperature and humidity. This is a relay. I'll flip it over so you can read it. We're not going to use this in this class. Relays exist so that a small voltage can control or switch a larger voltage. And so looking at the writing here, you see 10 amps and 250 volts AC, or 10 amps and 125 volts AC. And then on the bottom it says 5 volts DC. What this is telling me, and what this is, it's basically a glorified computer-controlled switch. By applying 5 volts, which is a tiny voltage, 5 volts DC, to these two pins here, I can basically switch 120 volts AC between these pins here. Now 110, 120 volts AC, that's what's in the plugs, the power plugs in the wall, of course. That's a dangerous level of AC current and voltage. So building a circuit around one of these, you can't use, for example, these sorts of breadboards or prototyping boards with AC. It would be too dangerous to put actual alternating current inside of these little pins here and these little connectors. So if you were building a circuit and using this to control something that's actually being powered by the wall voltage, the 110 volts AC, you have to build that circuit with much greater care towards safety. The little 5 volts and 9 volts that these things are using, we don't care much about safety with, but this we would. So we're not going to use this in this course, and if you do build a circuit that uses this to control 110 volts AC, be sure to learn the safe way to build a circuit that controls that kind of current. All right, we're down to 2 bags. Thanks for persevering and staying with me to the end. What's left are a few other little components, a couple transistors that again function like switching devices, a couple integrated circuits which can be configured to function like switching devices as well. The part numbers for these are all shown here, so if you have an application where you need to use those, you can learn more about what they're up to. Here, a little tilt switch that I'll show you. We'll use this in one of the early design challenges when we're playing with a sit-up counter. This has a little rolling ball inside of it. I don't know if you can hear it when I shake it. When the ball rolls to this end, because I've lowered that end of the component, it makes an electrical connection between these 2 pins. When it rolls to this end, the ball rolls away from those 2 pins, and that opens the circuit. So it's a switch, but it's a position-sensitive switch, so it can tell what angle it's being held at. Fun, very simple little sensor to use in some biomechanics operations. And then 2 speakers that come with this kit. Now, the part numbers are shown for these. One comes with this little covering on it that says remove before, what does it say? remove seal before washing. We can remove that because you're not going to wash this. Okay. There's the little openings where the sounds come out. You can see a little plus indicating the positive connection to these speakers. On the other side here, you see the wiring connections. Now, looking at these, you can see they're different. One has a green circuit board bottom, the other has this black epoxy bottom. And also, can you tell they're a little different in size? The one on the right there is a little thicker than the one on the left. So the 2 speakers are actually, one's a dumb speaker. This is truly just a speaker. It requires an AC or an alternating current applied to it to turn that into a corresponding noise with the same frequency as the current. So you can play with this, but it requires an AC, a time-varying signal to make a sound. This one here is more a smart speaker, or more like a buzzer. This can take in just a DC voltage, like 5 volts, or if I hooked it up to the battery there, it's taking in a DC voltage, and inside of it, it has a little additional circuitry that converts that DC voltage into a buzzing sound. Now, you can't change the frequency of it. It is what it is, and it's obnoxious. But if you have an application where you want an alarm or something to go off, this is a super easy way to make an alarm using just 5 volts DC. If you have an application where you want to change the frequency over time, this is a super easy way to do that, but you'll have to send it not just a DC voltage, but an AC signal, if that makes sense. All right, we're in the home stretch. What's left? Our last bag. This has got in it some important little sensors that we'll use in components. So these are first ones here. These are diodes. They exist to allow current flow in one direction only. We probably won't use those in Bioengineering 10. These little bug-looking things are switches. You can hear they click when I push them. You can jam this switch into your breadboard, and when I push the button down, it'll make an electrical connection between some of those 4 leads that you can see there. I'll leave it up to you to figure out which ones. And what else? This guy here, this very tiny component with just a little black nubbin on the top there, is actually a thermistor, a temperature sensor. And so its part number is shown, I think, up on that little cheat sheet as well. But the resistance of this varies as a function of its temperature. So in addition to the slightly more sophisticated temperature sensor that we talked about earlier, which also told you humidity, if you need a simpler solution, we can use an analog input on our Arduino, along with this guy here to measure the resistance of this component, which, like I said, in turn tells you the temperature of the component for making a thermometer or something like that. And then finally, the last 2 components I'll show you are photoresistors. Let's look at these guys from the end. See how close we can get to this and see it. You see they have this neat little, there it is, they have this neat little zigzag pattern on them. These are photoresistors, so just like the thermistor, where the temperature causes its resistance to change, these guys, their resistance is changed by how much light is shining on it. And so we will use these in a circuit we will build to measure your heart rate by measuring the amount of light that goes through your fingertip. That's called photoplethysmography, and basically with every heartbeat, the amount of light going through your finger varies by a little bit as that surge or that pressure pulse of blood goes out to your finger. And so these are very simple, very nice little light sensors. The amount of resistance change is proportional to the amount of light on the surface of them, and so they're useful in, again, a whole lot of different little bioengineering applications. And with that, oh my gosh, we've reached the bottom of the bin. Now the hard part, putting it all back. So thanks for watching this, and get your Arduino kit set up the way I have just set up mine, and you'll be all set for Design Challenge 1. Bye.